in SMPS, switch mode power supply, in switch mode power supply, you will find these regulators, SMPS. And this can be a buck type, boost type, or buck boost type, or flyback. Now, what is this? Just there is some internet issue, that is why my Zoom is not working. Please wait. So today we will see this type of regulator, that is SMPS. Okay. So just now, as I told you, there are different types of SMPS: buck converter or boost converter. Now, what is this buck and boost? Buck means, like, the step down. So if you want the output voltage less than the input voltage in regulator, what is the input to your regulator? It is DC power supply. Okay, and we want to regulate this, means we want to make it fixed. If there happens some fluctuations at input side or at the load current, still we want the DC voltage to be regulated, that is to make it constant in spite of fluctuations. So in buck converter or in buck type of SMPS, whatever output voltage you are getting, that is less than the input voltage. Okay. In boost converter, whatever output you are getting, that is boosted. That means it is greater than the input voltage. And in the buck boost, both modes are possible. In buck boost, what is happening? Both modes are possible. And in flyback, an output voltage is less than or greater than the input voltage generated as a multiple output. So you have here the chance of getting multiple output. This is what a SMPS is. Now let's see how this SMPS operate. Let's I use. Look at this diagram. What do you find here? Input. Look at this. Input is given. Okay. Then rectifier and filter means it is the part of that DC power supply. So if your input voltage is AC, you must convert it first to DC. Okay, because regulator is going to regulate the DC voltage. Okay, so if available input is AC, then you first convert it into DC. So that is why there is a rectifier and filter section which will convert AC into DC. Then there is a high frequency switch. Now, what is this high frequency switch? This is nothing but a transistor. Okay, what we are going to use here is a transistor. And this transistor is driven into saturation and cutoff, and this way it acts like a switch. Okay, so this is an electronic switch, high frequency switch, and this switch is nothing but a transistor which we are going to use as a switch. Okay, now who is driving this switch? Who is driving this switch? PWM. You see here PWM oscillator, means it's a pulse width modulation oscillator. I will use a whiteboard. So in simple fashion, you have here a electronic switch. What is this? Electronic switch. Let's label it as electronic switch. This is electronic switch. Okay. And what is there actually inside the switch? There is a transistor. So I'll draw here a transistor. So we have a transistor which is operated as a switch. So in what the block I am showing as a switch, is nothing but a transistor. Now what is connected to this switch? We are connecting a power supply which we want to regulate. Okay. So we'll connect here the power supply which is to be regulated. So let's say this is unregulated input, unregulated DC voltage. Okay, now unregulated means one which can fluctuate depending on the other parameter. So it is something which may change, and we want regulated means we want constant, we want unfluctuating. Okay, now what this how this switch is operating? So this switch is receiving some pulses. Okay, pulses. Now you know what is a pulse. It is receiving the pulses. Now who is giving pulses? There is a pulse generator. Okay? Pulse generator. So pulse generator is producing some pulses like this. So you have such kind of pulses are generated and that are given to the this transistor. So when they, we have seen transistor as a switch, like you have seen MOSFET as a switch. So last year you have studied transistor as a switch, and many times we have also discussed this. So whenever there is a high pulse, the transistor become on, and whenever there is a low pulse, transistor become off. So depending on these pulses, this transistor or this switch is becoming on and off. Now, when it becomes on, how when transistor is used as a switch, when transistor is on, what is the output voltage? We see when transistor is on, it start conducting. When it start conducting, maximum collector current IC flows. Okay, and VCC is equal to ICRC plus VCE. Okay, ICRC plus VCE. And in this case, what happens? VCC is a constant. Your IC becomes maximum, therefore your VC becomes minimum, and therefore you get here low at the output. Okay. So when transistor is on and when transistor is off, it is also producing such type of waveform. Okay, rectangular waveform. And then this waveform, where we are feeding this, we are giving it to the filter. So next block here is a filter again. Okay, remember this is a different filter than that of the power supply. So we have here a filter. Okay, and this filter, what it will LC type of filter, you can use the L and C combination here for ripple rejection. So you will be using here a filter, and then you will connect the output at the you will connect a load resistance, and you will get output of a regulator across this load. Okay, so this is your load resistance RL, and here what is available is regulated output voltage. So I have shown you the basic block diagram of SMPS, the simplest form of block diagram. Okay, in the book you can see the internal diagram as well. Okay, I will be telling about that also. But here I have tried to show you the simplest form of basic SMPS. So this is the block diagram, basic block diagram. What is there? You have input unregulated voltage. Okay, this is unregulated. This is given to a switch. The switch is driven by pulse generator. Everybody, are you getting? There is unregulated voltage which is given to the switch. The switch is driven with the help of pulse generator. So depending on the pulses, whether it is high or low, transistor will become on and off. When transistor become on and off, the output available here is again a rectangular waveform that is given to the filter, and the output unregulated DC voltage is available here. Now you will say that what type of output this is. Okay, so this is, these are the pulses. Okay, first of all, please let me know, can anybody tell me the different blocks I have shown? Can you repeat this? Yes, anybody? Anybody please repeat?
Electronic switch, pulse generator, and filter.
Filter. So who is driving electronic switch?
Pulse generator.
The pulses generated from the pulse generator are making it on and off. Okay. Now in this case, what type of output you are getting? Let us see that. Let's see what type of output you are getting. Now, depending on how much time this switch is on, you will get this pulse. Suppose now, let's say the switch is on for this time, so you will get high output. Then switch is off, then again switch is on for this time. So how you define the time period of this waveform? So this is T on time, and this is T off time. Okay. So T on plus T off is equal to total time. This is the total time of a waveform. Out of this is on, then this is off. Now it may happen that the time for which your transistor is on may change depending on when the pulse is arriving. Okay, so you can get this output voltage like this. You can get the output voltage where on time is higher. It is, you can make it for the on time of the output high and off time is low. It is also possible, right? Now in this case, see, F may remain same. F may remain same. But on and off time of the waveform is, I can vary depend by varying this pulse width. But if I if I'm able to vary this pulse width, if the on time of this pulse, look at the cursor, if the on time of this pulse is high, then I can switch the transistor and I can keep it in on condition for a longer time. Okay, if off time is less, I can make the switch off for less time. Now here, if this output of this electronic switch is on for longer time, is high for long time and off for less time, what we are finding here is the average. Okay, so out of this two, whose average will be higher? Can you tell me how you find average? Find the average DC voltage. Find the average DC voltage. Okay, so here, because this is high, longer for higher time, if you find the average of the voltage will be higher in second case. Okay, so I can vary the pulse width, and depending on that, I can vary the output pulse width of output on time and off time of the output of the switch. Okay, by varying the pulse width, I can change the on and off time of output of this switch. If higher is the on time, average voltage will be greater, and this is your output voltage. Okay, Now, what is duty cycle? I told you that this is total time period. Out of this is T on and this is T off. Now, let us define duty cycle. Okay. What is duty cycle? Duty cycle D is defined as, let's write, duty cycle D is defined as, now this is on time, this is off time. T on plus T off is equal to T, that is time period of a waveform. T total time is equal to T on plus T off. Okay, total time is T on plus T off. Now I will define here duty cycle as duty cycle D is equal to on time, okay, that is T on, divided by the complete time period, that is T on plus T off. Okay, so what is duty cycle? I can write this as D is equal to T on upon capital T, because this T on plus T off is nothing but T. So this is duty cycle. You can find the percentage duty cycle by multiplying this by 100. Okay. So now how much output you are getting? More is T on, more is duty cycle. Okay. This is on time. If you make this on time more, now how much, what you are getting? Actually, this is the input voltage. Okay. Look here. This is your input voltage, right? And this electronic switch, if I draw the equivalent circuit of this electronic switch, when this switch is on, I can show this like a closed switch, right? And when this switch is off, I can show it like a open switch. Fine. Okay. Now, when this switch is on, what actually is happening, that this input voltage is connected to the filter. It is filtered out and available at the output. And when this switch is off, this is disconnected. Okay. Are you getting what is the role of this switch? It is connecting V in or it is disconnecting V in to further stage. Okay. So output voltage, till what time you will get output? Till this V in is connected. So V in is available at the output for the time the switch is on, right? For the time the switch is on. Don't worry about when this, now don't look at the relation when this will be on, this will be off. That will be clear to you. So remember, when this switch is on, till that time it is getting connected, input is getting connected to the further stage, and when the switch is off, this is disconnected. So the time for this input is available, that time, till that time you will get the output voltage. Okay, so output voltage is equal to, in case of SMPS, output voltage VO is equal to T on upon T. Out of the total time period, the time for which output is switch is on, that is T on, multiplied by input. Okay, that means output is equal to VO is equal to duty cycle in into V in. Remember this important relation. VO is equal to D into V in. Output is equal to duty cycle into input voltage. Okay, got it? Have you understood? Are you getting this?
Yes, ma'am.
Yes, ma'am.
Sure, everybody? So in this figure, see, it is shown here a switch. That transistor, it is shown by a switch. So when the switch is closed, what will happen? When the switch is closed, this is some another shape. this input is getting connected, and when the switch is open, the input is getting disconnected. Okay. Now I'll show you, I'll give you the complete block diagram of SMPS. Okay. So if you understood the basic block diagram, you will understand the next diagram also. Pay attention. Very important topic. You will be studying this topic multiple times in other subjects as well. So you have a switch, right? The switch is nothing but a transistor. See now how I'm drawing this. I try to draw here fast, because if I draw, you will understand rather than I show it on the PPT. So let us first show a transistor. Okay, so we'll be using transistor as a switch. Transistor as a switch. Okay. So this transistor is going to act as a switch. So as I, okay, now you know at the collector we used to provide VCC, right? So here we will be providing, as in the last diagram I show you, that what is connected to the transistor, this is collector. We are giving input to the collector. What is our input? You know, for the operation of a transistor, you need to apply DC voltage at the collector. So this DC voltage is nothing but your V in this case. So here we are applying V in. Remember, this is a DC voltage. Then to the further stages, this is your emitter. This is the emitter. We'll be connecting here a diode. We'll connect here a diode. We'll see what is the role of this diode. And then we will be connecting a inductor. I told you that we are using filter. Okay, we are using filter here. So this inductor is for filtration. Okay, so there is a inductor. Then we connect a capacitor so that LC filter can be formed. So you have inductor L, and then this is a capacitor. Okay, this you are connecting at the emitter. Further, you will have, at this point you will get the regulated output voltage, and you will be connecting here a voltage divider. So voltage divider is consist of two resistors, R1 and R2. So this is your R1, this is your R2. Okay. Here the output voltage which is regulated is available. Okay. So this is regulated output. And the input which you have given here, this is unregulated. This is unregulated DC voltage. This DC voltage is unregulated. Here you are getting regulated output voltage. Okay, so your output is available between these 2 points, this point and the ground. And what you have connected there? You have connected here a voltage divider network. Okay, now what we will do, you know the concept of feedback now. The part of output voltage which is available across R2, that I will give to the error amplifier. So I connect here a error amplifier. I'll use here, in the last I have given you the how this error amplifier is used. So in the block diagram of LM317, we have seen the role. So, So error amplifier is nothing but your op amp. Okay, what you are connecting to this, it's like a comparator. So it is receiving the voltage which is present across R2. What is present? See, output is present here between this terminal and this terminal. The part of output voltage which is present across R2, that is connected to the error amplifier at positive terminal. Okay, I will call this as EA, error amplifier, and this is nothing but a comparator, remember. And to the inverting terminal of this comparator, we will connect a voltage reference voltage with which we will compare the output voltage. Okay, so this is reference voltage. This is reference voltage. So this is a reference voltage, some value, some voltage with which we will compare this voltage. So what happens, whatever is the output voltage, some part is given here. So now this amplifier, error amplifier, is comparing the output voltage with the reference voltage, and accordingly it will generate a signal. Okay, it will generate a signal. So you know how comparison takes place. If the voltage at positive terminal is greater, it will produce the output plus Vsat. Okay, high. And if the reference voltage greater than this, then it will produce the output minus Vsat. So therefore, this error amplifier will generate such type of rectangular pulses. Are you getting? This is op amp, this is positive terminal. So input at whichever terminal is greater, the output plus Vsat or minus Vsat will be produced. So if the input at positive terminal is greater, that is non-inverting terminal is greater, it will produce output plus Vsat. Okay, if this is reference voltage is greater, it will produce minus Vsat. Okay, this is how the comparator operates. So depending what this is doing, it is sensing the changes in the output, and it will denoting whether the output has increased or decreased as compared to reference voltage. That's it. Then this output voltage is further given to another comparator. Okay, this is given to another comparator. So you have one more comparator here. You have one more comparator here. And what this comparator is receiving, it is at one end, it is receiving the output of error amplifier. Okay, at one end, it is receiving output of error amplifier. It is given to the comparator and it is connected to inverting terminal. And what is there to the positive terminal? There is another oscillator or a triangular wave generator. Okay, there is a triangular wave generator. So this block is a oscillator which is generating the triangular wave. We'll call it as triangular wave generator. Triangular waveform generator. Okay. So and this block is nothing but a comparator. This is your comparator. Remember the block diagram, I have drawn this. Now output of this is given to this transistor. Okay, now this diagram is complete. This transistor is operated as a switch. Okay, this is nothing but your electronic switch. Okay, this is electronic switch. I'll repeat once again. Everybody will pay attention. This is the electronic switch which is becoming on and off depending on the input. Okay. Now, the output of this switch is given to the LC section, that is filter. So this is a filter. And here your regulated output is available. The part we are connecting here a voltage divider network. So part of output voltage which is available at across R2, it is given to another comparator to which we call error amplifier. So this comparator is comparing the output voltage and the reference voltage. So whenever output voltage is higher, it will produce high pulse, and if the output voltage is lower, it will produce low pulse. So accordingly, it is generating rectangular pulses. These are given to another comparator at its inverting terminal, and this comparator is receiving triangular wave at the non-inverting terminal. So how this comparator is working? Let's see. I'll explain you. So now you know op-amp how it operates. We have performed an experiment. Okay. So this is a comparator. So comparator is receiving uh, such type of rectangular waveform. Okay. And it is also receiving at another end the triangular waveform. What it is receiving? A triangular waveform. Like this. Okay. Now what this is comparing, this rectangular waveform and the triangular waveform. So what kind of output it will provide? How it will provide the output? It will compare every time the amplitude of this and this. Amplitude of a rectangular waveform and the triangular waveform. So you see from this point to this point, here this peak, I will indicate it by red color. Here the triangular waveform output is becoming higher. Okay. Till that time, your rectangular waveform, up to here your rectangular waveform, the amplitude is high and triangular is increasing slowly. So rectangular waveform output is high, where it is connected to the inverting terminal. So it will produce output equal to minus Vset, or like this. Then in this portion, rectangular waveform has become greater. So where rectangular waveform is connected at inverting, non-inverting, so it will give you output plus Vsat till this point. Okay. Then from this point again, uh, value of input is 0. I mean, value of rectangular waveform is 0. So again here your triangular waveform is greater till this. So it will give you higher. Now here triangular waveform is less till this time, and it is becoming higher here. So it will change the output. I'll draw it in another way, easier way I will draw. This is the triangular waveform. Okay. Suppose output here is suppose the amplitude of triangular waveform is 2 volt peak, and the output voltage present here is 1 volt at the error amplifier. Let us say this is 1 volt. Okay. So I draw this 1 volt signal here. So 1 volt DC is the output. For example, I am giving, so its value will be plus Vsat or minus Vsat, or better you take this is 12 volt and this is 10 volt. Okay. So the portion from above 10 up to 12, who is greater? Triangular waveform is greater, and portion from 0 to 10, who is greater? This DC voltage is greater. Okay, so how you will get the output? Here, from 0 to this point, from 0 to 10 volt, DC voltage, that is error amplifier voltage is greater, so you will get output equal to minus Vsat. Now here, at this point, the triangular waveform is becoming greater, so your output will become plus Vsat. Again here what is happening? The DC voltage is greater and triangular waveform is less, so you will get output equal to minus Vsat. Now there comes a negative peak, so again your DC voltage is higher, so again your output will become minus Vsat till this point. And here the output is switching to, I am explaining you in much detail. Okay? So you will get such type of output. Okay. Now suppose this output is greater than 10. So this waveform will, this voltage line will be shifted here. So in that case, the time where it is triangular wave is higher, it will small, and you will get smaller on time. Now look here, this is on time, this is off time. So if I shift this DC level, I can vary the on time. Are you getting? If I shift the DC level, I can vary the on time. Okay. So this way, triangular wave and the output of error amplifier are compared. Now tell me, if output of error amplifier is high, so if I want to make this pulse width greater, means on time high. So what I can do if I want to make on time high? This is my triangular waveform. I want to make on time high. So what I will do? If this DC level output of error amplifier is less, so what will happen? Now this is the time till which output of error amplifier is high, so I will get minus Vsat. From this point to this point, I will get plus Vsat. Now this portion above this DC line is high, so I will get output here high. Now this is again high, so now at this point only my output is going to, no, at this, sorry, at this point the amplitude of triangular wave falls. Amplitude of triangular wave falls, so this will become, again it will be switched on this time. So if this DC level is shifted down, the on time will become high. If this DC level is increased, on time will be less. Now depending on the signal which is present here, the transistor will become on and off. This is what the output of comparator. Output of a comparator. Okay. So depending on and off time, the comparator will produce here the waveform whose T on can be controlled with the help of, means that T on depends on the output of error amplifier. So more is the more is the time T on, for more time transistor will become on. Okay, and it will connect the this sub unregulated voltage to the further section of filter. And if this is less, it will connect it for less time. So have you understood this? Are you getting? I will ask one line question and you have to answer. What is this? Everybody, what is this? What is this?
Transistor.
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 Transistor is used as a
Electronic switch.
electronic
Electronics.
switch. Okay. Who is making this switch on and off? Who is making this switch on and off?
Output of comparator.
Very good. Output of comparator is on. If output of comparator is higher on time, so for higher time switch will be on. If it is having lower on time, for lower time switch will be on. Okay. So on time depends on this two input. Okay. Yeah. Where from this comparator is getting input? हा कंपॅरेटरला कुठनं इनपुट मिळत आहे? Answer the question. This comparator is getting which inputs?
From
Hello?
error amplifier.
From error amplifier. One input is from error amplifier. Another input?
Triangular generator.
Triangular wave generator.
Waveform
So it is
generator.
comparing the output of error amplifier with the triangular wave and accordingly it is generating the pulse wave. Where from the error amplifier is getting input? One is
Reference voltage.
reference voltage. Another is output
Ah,
voltage. Okay. Another is output voltage. Whatever DC voltage is given to the collector, that is connected only when the switch is on. Okay. Now if I call that this switch, if I represent this switch as off switch, like so for off switch I can show it like this. जर स्विच ऑफ असेल तर हा डीसी व्होल्टेज पुढे पुढच्या सेक्शनला कनेक्ट होईल एलसी सेक्शनला, आणि हा स्विच जर ऑफ असेल सो इट विल ऍक्ट लाईक अ ओपन सर्किट आणि हा डिस्कनेक्ट होऊन जाईल. इट इज लाईक दॅट मच सिम्पल थिंग. ओके. नाउ लेट अस समराइज हियर. सपोज हा अंदर हे जे आउटपुट व्होल्टेज आहे हे वाढलंय. लेट से VO is increased. Let us say output voltage is increased. Okay. Output voltage try to increase. So what will happen to the voltage drop across R2? Whether it will increase or it will decrease? Suppose output voltage is trying to increase. So what will happen to the drop across R2? Students, where is output voltage present between these 2 points? If the total output voltage is increasing, see the current, this is the current is flowing through R1 and R2. Okay. If total output voltage is increased, so what about the voltage across R2? Current same आहे, voltage drop चं काय होणार? Not getting. Suppose output is 10 volt. Suppose R1 and R2 are same or different. So let us say 4 volt is dropped across R1, 6 volt is dropped across R2. Now this value is increased. हे वाढत आहे अनरेग्युलेटेड सप्लाय त्यामुळे किंवा हे वाढत आहे. So let us say it has become 12. So what will happen? Will not these two things change? हे 12 झालं तर करंट चेंज झालं. Are you getting or not? How you calculate the current flowing through this branch? Are you not getting? Tell me frankly. Current flowing is I. How you calculate current I? VO upon R1 plus R2 हा एवढा करंट आहे. Got it? Current किती आहे? This is output voltage present here. The current which is flowing is equal to V upon R1 plus R2. Is it clear? Current कसा काढलाय मी हे कळलं का?
yes, ma'am.
Yes, ma'am.
Everybody. How I find it this current? Everybody.
Yes, ma'am.
Yes, ma'am.
Okay. Now when I say that output voltage is increasing, म्हणजे याचा न्यूमरेटर जर वाढला तर करंट वाढणार की नाही? वाढणार की नाही?
Yes, ma'am.
आधी 10 व्होल्ट होता, नंतर 15 व्होल्ट झाला. जर व्होल्टेज वाढलं, हा न्यूमरेटर वाढला तर करंट वाढणार. ओके. नाउ व्हॉट इज द ड्रॉप अक्रॉस R2? I into R2. बरोबर. व्हॉट इज VR2? व्होल्टेज अक्रॉस R2 किती आहे? I into R2. जर हा करंट वाढला तर V2 वाढणार की नाही? कारण R2 तर कॉन्स्टंट आहे. ओके. वाढणार की नाही? जर आउटपुट व्होल्टेज वाढलं तर व्होल्टेज ड्रॉप अक्रॉस R2 वाढणार की कमी होणार?
वाढणार.
वाढणार.
आणि जर आउटपुट कमी झालं तर? इफ आउटपुट इज डिक्रीज, हे आउटपुट जर डिक्रीज झालं तर ड्रॉप अक्रॉस R2 विल ऑल्सो
Decrease.
decrease. Got it now? Okay.
Yes.
Yes. So when output, now we will consider the case. Now we will consider the case that output voltage is trying to increase. Output वाढले. त्याच्यामुळे काय होणार? Voltage across R2, VR2 will also increase. बरोबर? Now what is our feedback voltage? हा voltage across R2 म्हणजेच हे काय कुठलं voltage आहे? Feedback. Okay. Now suppose this voltage is increased, what will happen to output of error amplifier? The error output of error amplifier. Where we are connecting VR2, that is feedback voltage, to the positive terminal. Suppose हे voltage reference voltage पेक्षा वाढलं. Suppose output voltage which we are connecting here, it has increased than reference voltage. So what will be the output of error amplifier, whether it will increase or decrease? Plus Vsat राहील का minus Vsat राहील? मी तुम्हाला सांगितलंय की जे टर्मिनल्स आहे तुमचे प्लस आणि मायनस, याच्यापैकी ज्याचं इनपुट मोठं, विथ दॅट साइन यू विल गेट हिअर आउटपुट Vsat. मग आता कोणाचं मोठं झालंय? टेल मी. This voltage is increased, so the voltage applied at this positive terminal is increased as compared to the reference voltage. So error amplifier voltage will वाढणार की कमी होणार बाळांनो?
Increase.
इन्क्रीज
वाढणार.
होणार. बिकॉज दिस व्होल्टेज, आपलं वाढलेलं व्होल्टेज कुठे आहे? पॉझिटिव्ह टर्मिनलला ना. मग ते व्होल्टेज वाढलं की याचं सुद्धा व्होल्टेज वाढेल. आणि बघा इथे, इफ दिस व्होल्टेज इज इन्क्रीज्ड, now this second comparator is comparing it with the triangular wave. Okay. Second comparator is connecting this with the triangular wave. So now let us consider the output of second comparator. याचा T on time बघा. जर हे व्होल्टेज वाढलं तर ऑन टाइम कमी होणार की जास्त होणार? आय हॅव शोन यू हिअर. But we have considered VO increase, therefore VR increased, therefore error output increased. Okay. Hey, output, look at this case. Look at this case. Here I have shown 10 volt. And here I have shown, let's say, 5 volt. What happened? Oh, so sorry. Disconnected. I haven't saved it. Hello?
Yes, ma'am.
Can you
Yes,
see my
ma'am.
screen?
No, ma'am.
No, ma'am.
It disappeared just now, right?
Yes, ma'am.
Oh, everything is lost.
Ma'am, there only 1 minute left for presenting.
Oh, yeah. Because of this internet, now I got disconnected. Is attendance started?
No, ma'am.
Is attendance started?
No, ma'am.
Okay, let it be. I'll take the manual one. The problem is my whiteboard has lost. Okay, anyway, we will discuss. If output voltage increases, what happens? The voltage across R2, which is our feedback voltage, also increases. Why I'm getting disconnected? I don't know. Zoom is getting disconnected. Okay, let's discuss orally. Okay, today's lecture we have completely understood what happens in SMPS. Okay, then in the next lecture I will be completing the remaining type. So remember, if the output voltage increases, voltage across R2 increases. Therefore, error output amplifier, the output of error amplifier also increases. आणि जर एरर एम्प्लिफायरचा आउटपुट वाढलं तर टी ऑन टाइम कमी होणार, कंपॅरेटरचा टी ऑन टाइम कमी होणार. ओके, आणि तो जर कमी झाला तर ट्रान्झिस्टर जो आहे हा कमी वेळासाठी ऑन राहील. ट्रान्झिस्टर विल रिमेन ऑन फॉर लेसर टाइम. ओके, therefore average output will decrease. It is connecting the unregulated DC voltage to the further filter supply for lesser time. ओके, त्याच्यामुळे आउटपुट कमी होईल. म्हणजे एका साइडला on one side the output is trying to increase, so circuit is taking such a action that it will be brought to its normal value. आणि सपोज आउटपुट जर कमी व्हायला गेलं, if output is decreasing, तर काय होईल? Suppose output decreases, then voltage across R2, suppose VO decreases, then voltage across R2 will also decrease. If this voltage is decreased, then error amplifier's voltage will also decrease. If error output amplifier voltage is decreased, the next comparator which is producing the pulses to drive the transistor, it's on time, T on time will increase. And when T on time increase, V in is connected to the filter for longer time, and therefore output will increase. Okay, the action is such that whenever output try to decrease, circuit make it to increase to its normal value. It's not getting shared. Is increasing to its normal value, and if it is not, if output is increasing, circuit will bring it back to the normal condition by the action, or if it is, if, whether it is increasing or decreasing, the circuit will take such action that it will be brought to normal value. Next time we will be learning the regulators. My board was not visible to me. Let's take the attendance. Execute. What is today's date? 13.
30.
Please give your attendance fast. Yeah. Nilesh Agha.
Present,
If I,
ma'am.
can you see the screen?
No.
No.
Whatever I taught you on the whiteboard, was it visible to you? ते दिसत होतं तुम्हाला?
Yes, ma'am. Now visible, ma'am.
नाही, आधीच दिसत होतं का? दिसलं ना सगळं?
नाही.
म्हणजे मी जी डायग्राम काढला पूर्ण, तो तुम्हाला दिसला नाही?
हो मॅम, दिसली.
दिसला मॅम.
हो मॅम.
पूर्ण शेवटच्या काही मिनिटांमध्ये आय थिंक इट हॅज गॉन. Otherwise, okay.
Yes.
Now when I mark you tick here, you can leave the meeting. Nilesh Agav.
Present, ma'am.
Aditya Andurkar.
Present.
Pejal Bagmare.
Present, ma'am.
Parth Baviskar.
Present, ma'am.
If I mark, you can leave the meeting. Vaibhav Bandarge.
Present, ma'am.
Vaibhavi Bhosle.
Present, ma'am.
Uday Borse.
Present, ma'am.
Harshada Chaudhary.
Present, ma'am.
सिमरप्रीत चावला,
Present, ma'am.
ऋतुराज चोलके,
Present, ma'am.
कल्पेश देशमुख,
Present, ma'am.
हर्षद देशपांडे, हर्ष धनावडे,
Present, ma'am.
Present.
you are not
Number
audible.
12.
Please write. Rutika,
Present, ma'am.
Vivek,
Present, ma'am.
अर्पिता,
Present, ma'am.
साहिल हिवराळे,
Present, ma'am.
कल्पेश जाधव,
Present, ma'am.
समृद्धी काकडे,
Present, ma'am.
अभिषेक कानडे,
Present, ma'am.
साक्षी
Present,
कारके,
ma'am.
तन्मय खैरनार,
Present, ma'am.
तन्मय, अभिषेक लवाटे,
Present, ma'am.
यश लवाटे,
Present, ma'am.
श्रुती वंडाले,
Present, ma'am.
मियालाल मुल्ला,
Present, ma'am.
ऋषिकेश मुंगसे,
Present, ma'am.
साहिल नायकरे,
Present, ma'am.
वरुण नायकरे,
Present, ma'am.
पियुष नेमाडे, पियुष, चेतन पाटील,
Present, ma'am.
प्रथमेश पाटील,
Present, ma'am.
समृद्धी पाटील, समृद्धी, आदित्य पवार,
Present, ma'am.
ओमकार फरांडे,
Present, ma'am.
संजय प्रसाद,
Present, ma'am.
प्रथमेश लांडगे,
Present, ma'am.
प्रथमेश, ऋतुजा बनकर,
Present, ma'am.
पार्थ सावंत,
Present, ma'am.
पियुष सावकर,
Present, ma'am.
सुयश शहापुरे, अनुष्का शेवले,
Present, ma'am.
शुभम श्रीसाठ, अंकित सिंह, तेजस सोनावणे, सलोनी सोनकांबळे,
Present, ma'am.
अक्षय सुतार,
Present, ma'am.
अभिषेक तिंगाले,
Present, ma'am.
यज्ञेश वरपे,
Present, ma'am.
वैभव वाखरे.
Present, ma'am.
Okay, please check the absent student. Tanmay Khairnar, Piyush Nemade,
Present, ma'am.
Samruddhi. Who is this Tanmay? Okay, Piyush Nemade, Samruddhi Patil, Suyash Sahapure, Shubham Shrisat, Ankit Singh and Tejas Sonavne. If you have mic problem, you please write in the chat box and can leave the meeting.